Hi and welcome to measurement video 2. In this video we're going to look at surface area, and we're going to look at some surface area stuff that you surely should know from previous learning. So we're going to look at cubes, cuboids or rectangular prisms. We're going to discuss the common units related to surface area as well, and we'll do some examples. So first of all, the surface area is the total sum of each exposed face of a shape. So a standard three-dimensional shape, that'll be quite easy, but there are some where you might be dealing with inside exposed faces, or you might be dealing with some quite complex shapes. So just keep in mind, it has to be a face that is exposed in some way on that shape that's added up. And a cube, first of all, is relatively simple. So like our properties in the area video, here we have a cube which has side length, let's say S, which means that is S, and that is S as well, and they're all equal. And so the volume, so the surface area of a cube, which I'm going to now call TSA, total surface area, and then I might use SA to denote components of it. TSA is equal to S squared plus S squared plus S squared plus ... heaps of S squareds, and in total there are 6 S squareds. And let's have a quick look at that. So first of all, there is this S squared on the front, on the side face there, and there's an S squared on the front face, and there's an S squared at the top. There is an S squared around this side, there is an S squared underneath the base, and there is an S squared around the back. If you have a look at a cube or anything that's a rectangular prism right now in front of you, you'll see it has 6 sides. So there's our total surface area of a cube. Moving down to rectangular prism, this time we have like a cube shape, so still a prism, but we have 3 dimensions that could all potentially be different. So the first dimension I'm going to call B for base length, and the second dimension I'm going to call H for height. It's reasonably dull so far. And the third dimension I'll call D for depth. And of course these may take other names, so just be aware of that. D is commonly called W for width as well, and whatever, it doesn't really matter. So we have total surface area in this case is equal to 6 different sides added together. So the surface area is 6 different sides added together. So let's start first of all in green with this side here. And this side has an area equal to HD. And you'll notice that this side is equivalent to this side over here. So we have 2 HDs. And I might write them down as just HD plus HD in our surface area. And now in blue, let's do this side underneath, which is the base. So I'll just scratch out the base there, and this side has area equal to BD. And you notice there's a base on top as well. So the top side's the same as the base, and that's also BD. So we have plus BD plus BD. I don't really know what was going on with my B there, but that's all right. And of course, last we'll do this orange one, which is going to be a little bit hard to visualize, but it's basically the front shape. So I'm going to shade over a bit of green and blue to get there. And you'll notice that the back has the same area. So the front shape has an area of B, equal sign there, B times H. And so the back shape also has an area of BH. And so we can write down here plus BH plus BH. And that's our total surface area. Better written as 2HD plus 2BD plus 2BH. You can factorize a 2 out. There's a few other little representations there, but that's essentially it. So often when you're dealing with a rectangular prism, you're just going to have to go and find 3 different areas, multiply them all by 2 and add them together. Some contextual problems will be something like a box, which may not have a lid. So be really aware of the context and the meaning of that context and what it shows, and work with that context to calculate your surface area. Lastly, I'm going to talk about a circular prism. Now, what I haven't done yet is gone to nets, but I am going to go to a net for a circular prism. Let's just talk very quickly about this net of this rectangular prism. So if the base rectangle looks like this, with B and D, then our net would look like this. We'd have an HD here, another shape there, another shape there, and we have these 2 wings. And when we fold this up, those 2 wings go in to fill up the shape. So this will be H, and this will be H, and this will be D again, and then we'll have HD on the wings. So you can see that folds up. A circular prism, you have to think a little bit more abstractly about what happens. if we cut, let's say like a tin can down this dotted line, and imagine it doesn't have any lid or any base, so it's kind of like a piece of A4 paper rolled up. If you roll it up, you get that kind of cylinder shape. So it actually makes, if you unroll that bit, it makes a rectangle. And of course there is a top and a bottom, and they exist here and here. So if you roll this up, then you can fold the top and bottom in, you'll have a cylinder. So this is how a cylinder looks, a circular prism. Now let's have a look at what values go in here. So I'm going to start by just putting my common values on there. This one is my radius. And of course, if I drop right down the middle, I'm going to, because I'm original, call that the height. So I've got radius and I've got height. So I'm going to have a look at how those things relate to my diagram here. Well, first of all, that's my height. So I've kind of orientated around a different way. But you can see that if you're going to roll that up and then put the top and the bottom on, that would be the height. And of course, inside of here, I have two radiuses. And my writing get a little bit small now. I might just zoom in a little bit. So this means that the area here is equal to pi r squared. And the area here is also equal to pi r squared. The difficult bit is this rectangle. Calculating the area of a rectangle is quite easy, but we need to know this side length. So now let's just imagine we rolled that up and sat those circles on top. Hopefully you'll realise here that this side length, where that green arrow is there, is actually just the circumference of the circle, because we're rolling it up around the edge of the circle. So the side length is equal to 2 pi r, which means that the area of my rectangle is equal to h times 2 pi r, and that gives me an area equal to 2 pi rh. And now I go back to the reliable TSA, total surface area, is equal to pi r squared plus 2 pi rh plus pi r squared. Getting those just in order there. And simplifying this, I have 2 pi r squared, a top and a bottom, and 2 pi rh. This is perfectly fine as your formula, but sometimes it's factorized out to be 2 pi r times by r plus h. Now, if you have access to a formula sheet or you're doing work at home, you could refer to either of these. This is the really good one for understanding. It's a breakdown of why that's the area. If, on the other hand, you have to remember this formula, well, the second one here is probably better. 2 pi r is the circumference. We just do circumference times the sum of the radius and the height. And that might be a little bit easier to remember. So you have to deal with it how you need to deal with it. So there we have it. The surface area of a cube, cuboid, and a cylinder. Now we'll zoom out a little bit here and have a look at the units. The surface area is always measured as an area, and therefore it has two dimensions. So you'll expect to see surface area as millimeters squared, centimeters squared, meters squared, kilometers squared, or perhaps some of those imperial units like miles squared or feet squared. Either way, it's going to be a length squared. And when you get some contextual questions, you need to be careful that you are dealing with the same unit the whole time. If you have a question that is all in millimeters, but one of the measurements is in centimeters, you have to make that conversion to ensure that it actually works.